So as a last experiment, we have experiment number 9, that is simple robotic system. And in this simple robotic system, it's a huge large area, so we will focus only on a robotic arm for this particular lab session. So this robotic arm is a artificial arm that is analogous to human arm, and it has more capabilities than human arm. Okay, in some sense. And these robotic arms, why are we studying this robotic arm, is because this is widely used in manufacturing industry assembly lines. In manufacturing industries. Okay, the aim is to develop a working model of a simple robotic system. Working model of a, so we are not going to develop it, rather we are going to play around with the kinematics part. Kinematics. So I will tell you briefly what kinematics is in the next slides or few subsequent slides. So we are going to vary my theta 1, theta 2, theta 3 and theta 4 and theta 5. So all these things are my joint angles. What these joint angles or degree of freedoms. So I will also tell you in details what these things are in subsequent slide. Just to motivate you, this is a Mitsubishi MoveMaster 2RM robotic arm. It has certain component. It is having waist, having shoulder, elbow, maybe wrist that could bend and roll. So all these things are there in your human shoulder as well. So you have a shoulder, so you have a knee, so this is your elbow, this is your wrist, and also you have waist. Okay, essentially these waist, elbow, wrists and shoulders are called joints of any machine. If we talk about machines, so these are joints in mechanical terms. Okay, and two joints, that is shoulder and elbow, is being connected by your bone. Okay, this bone is called as mechanically called as link, and this link and joints together, if they do certain tasks, is called mechanism. Okay, and this mechanism falls under a category of kinematics of machines. So in this robotics course, we are primarily focused, or we are primarily concerned about the kinematics of the machine rather than the dynamics of machine. So what is the difference between kinematics and dynamics? Any idea? Anybody? आप लोग कुछ पता है डायनेमिक्स क्या होता है, काइनेमेटिक्स क्या होता है? कोई भी बोल सकता है. ये वर्ड कभी सुने हैं, डायनेमिक्स, काइनेमेटिक्स? Have you ever heard about these words?
In kinematics, we don't look for the cause of motion, but in dynamics, we do.
Very nice, very nice, very nice, lovely. Yes, you are right. So kinematics, we are not concerned about how the forces are acting. Okay, we are more concerned about the path of the motion, or how the motion was happening, whether from location A to location B it has gone from this way, or it has gone from this way, or straight, or maybe some other things. Okay, So we are more concerned about how the things are moving, and in dynamics we look for an answer of why the motion was happening, whether it was acted upon by the force or by some forces. Okay, and we actually apply F is equal to ma to get the whole physics of the problem in the dynamics. Okay, thank you. I mean, it was a good answer. Okay, and in robotic arm we are more concerned about the path that is traversing. I mean, this robotic arm in right hand side, you can see it is this end effector or the gripper is going from here to here by certain following certain path, and this part has been achieved by taking the angles in certain way. So theta 1 was 90 degree, theta 2 was initially some, let's suppose some degree to, it has rotated to some degree, let's suppose theta 2 is equal to 30 degree, it has rotated, then it has been rolled, maybe theta is equal to 175 degree, or theta 3 theta 4 again rotated by one, probably 18 degree or something. So your theta's values are changed accordingly to get this desired path, because in assembly line you want to, either you want to drill something, you want to pick some stone or pick some screw or bolt and put it somewhere, so you should follow a certain path to achieve your task. And that is why the kinematics part is more uh, desirable in any robotic system. Okay, dynamics part is also desirable, but not that what kinematics part is of great importance. Okay, again, just to motivate you, this is a robotic arm which is doing a logical operation. So it is taking stones from 4 places and it is staking on top of it logically, probably in certain order, maybe bigger to smaller or something. So this is a real environment, and this window is essentially what robot is seeing through image processing. Okay, and it is based on the image processing data. It tells that okay, how much volume or mass the stone is having, and so logically I should put in this fashion, and this logic should be given by computer engineers by coding or by certain programming. Okay, so this is where you computer engineers are sitting, and you decide the kind of brain. You guys are the brain of any automated system. You guys are making the brain of any robotic system. Basically, you are sitting there, and that is why this computer science engineering is an evergreen engineering branch, and it's a it has its own beauty. So, as a definition, a robotic arm is a mechanical arm, usually programmable, with similar function to a human arm. Okay, what your human arm is doing, you can actually rotate your shoulder. Also, I mean, you can also rotate your waist in order to take something, some object that is kept in behind to you. You can vertically rotate your arm, you can rotate your elbow and wrist also, you can rotate in certain fashion. But the automated or the machine arms are having more capabilities than your human arm once it is programmed logically. The arm may be the sum total of mechanism or maybe part of more complex number. So mechanism is again this the combination of any link and joints that you have. The end effector or the gripper or the robotic hand can be designed to perform any desirable task such as welding, gripping, spinning, depending upon the applications. And there is a whole lot of applications that these robotic arms in manufacturing industries in mechanical engineering. So this is your robot. There is a drive unit, probably the power unit that is giving the power from taking the power from the power source, and it is converting and giving the appropriate power to the robots. This is a teaching box. You can manually enter your theta values. Let's suppose theta 1 should be 0 degree, theta 2 should be, so it can rotate this way, This guy can rotate this way, this wrist can rotate this way, this wrist can rotate either this way, and also it can roll. So this is called roll, and this is called probably pitch in terms of aerodynamics, if you can pitch or roll or something. Fine. So this is manually you can enter these theta values, and you guys are sitting somewhere here, the computer, the brain of the thing, you can do some coding. It will give the information to kinematic controller. It's kind of logical operation, electronically it will do. Obviously computer cannot do I mean hardware wise it cannot do, so it's kind of hardware integration of logical operation, something. This is a complete set of any robotic arm. Okay, but we are not more concerned about all these components, but we are more interested in varying this theta 1, theta 2, theta 3, theta 4 and theta 5, and by knowing these theta values, if at all these theta values are known, and also this link lengths are known, we need to find the position of the end effector. What is my x, y and z? Okay, so that dynamics, or that kinematics will be coded in your computer in order to give you a desired result. This I have already told. Overall size of that Mitsubishi that is developed by Japan, 27 kgs of payload, 1.2 components we have already talked. Okay, the main thing we are going to discuss here is the kinematics part of any robotic arm. So the first the kinematics part can be divided into two things. That is, first is forward kinematics. So in forward kinematics, the aim is to find the end effector position x5, y5, z5. Okay, if at all these theta values or q1 values are known. So theta 1 is known, theta 2 is known, probably this is theta 2. Theta 2 is known, how much angle it has swept. Theta 3 is also known, theta 4 is also known, theta 5 is also known, and also these link lengths. So L1 is known, probably L2 is known, L3, L4 is known. So in order to get the final position, let me not talk about this whole complex robotic system. Let me start with a simple planar robotic system. Let's suppose this is a wall, this is a hinge, okay, and this is your link basically. So link has certain length L1, and it is making, so this is your x-axis, this is your y-axis, and it is making, at currently it is making theta 1 angle, and it has length certain angle L1 which is known. This is also known. So by just basic mathematics or algebra or trigonometry, are we able to know the position of this end effector x of this single link, one link and one joint? So x1, y1, could we know that? Anybody? Let's suppose my theta value is 45 degree and my link length is 1 meters. Will I be able to get the information of x1, y1?
Yes.
Yes. How?
Yes, sir.
How much could be the value x1, y1? Somebody tell me quickly.
Cos theta
One by
divided
root two.
Okay, so I could,
1 by root 1, 1 by root 2.
so this is my x1, this is my, or this is my y1, this length. So sine theta 1 is equal to p by h, that is perpendicular by hypotenuse. So my y1 is L1 sine theta 1, L1 is 1 sine 45 degree, 1 times 1 by root 2, 1 by root 2. Similarly, x1 would be also cos 45, L1 cos 45, is also 1 by root 2. So x1 y1 is nothing but 1 by root 2 by 1 by root 2. Okay, so we have one link and we are able to find my end effector position through some basic trigonometric operation. We know some Pythagoras theorem and something, and we could apply, and single case के लिए हमें आराम से मिल जाता है. If we have complex systems, we can also do that, right? We can also do that. Let's suppose my second end effector, second link, is having length L2. Okay, and it is making theta 2 angle from this way. Okay, and now we can actually estimate x2 y2, isn't it, by some algebra. Okay, so whatever the algebra that it takes, we generally put it in certain matrix form, and we call this matrix as transformation matrix. Obviously, I cannot tell you the whole robotics or whole kinematics. So this kinematics of machine is a whole course that you need to study to understand this. So in one class, एक क्लास में हम कुछ भी नहीं, मैक्सिमम कुछ भी नहीं बता सकते हैं एक्चुअली में. सो जस्ट ओवरव्यू हम दे रहे हैं, बट इतना ओवरव्यू हम दे रहे हैं कि आप लोग मोटिवेट हो सकें कि कितना ब्यूटीफुल चीज़ लोगों ने बनाया है. हमारे पहले के एंसेस्टर्स ने हमारे लिए कितना ब्यूटीफुल और कितना प्रिस्क्राइब्ड चीज़ हमें दे के गए हैं वो लोग, बहुत ही अच्छे तरीके से. वी शुड अप्रिशिएट दिस एक्चुअली. सो इन ट्रांसफॉर्मेशन मैट्रिक्स we multiply with initial condition. Let's suppose I have initial 1x1 y1 z1. We multiply with certain angles, certain identities of this sin theta cos theta. So इसमें sin theta cos theta पड़ा रहेगा probably, I don't know, maybe multiplication of sin theta cos theta 1, sin theta 1 cos theta 2 plus any identity, I don't know, maybe some relation यहाँ पड़ा रहेगा. If you multiply with this transformation matrix, you can actually get x5 y5 z5, and this is called knowing the final position end effector. If at all you know the theta values, the degree of freedoms, and the link lengths, is called forward kinematics. And this is what you should, as a computer programmer, you should program in such a way that it should understand this particular guy should understand what forward kinematics is all about. So you should provide a brain to this guy in order to do certain tasks. Isn't it beautiful? Another way of doing understanding this whole scenario is called inverse kinematics. So in inverse kinematics, so essentially link lengths are known, L1, L2, L3 and L5 are known, and we know that what is my end effector. So I also know that what is my x5, y5, z5. If at all these are known, what are the sets of values theta 1, theta 2, theta 3, theta 4 and theta 5 should satisfy my goal. Okay, it could be, you can have n number of sets. You can have first set 30 degree पहला रखें, 40 degree, 0 degree, 5 degree, 2 degree. Maybe this could be the answer to get your job done. But probably एक कान को पकड़ने के लिए आप नॉर्मली कान भी पकड़ सकते हैं और उल्टा करके भी, वैसे हाथ उल्टे करके भी पकड़ सकते हैं, राइट. सो दूसरे तरीके से भी आप कान पकड़ सकते हैं. मे बी 180 डिग्री, 45 डिग्री, certain maybe minus 25 degree, maybe I don't know, some certain set of angle. That is also a solution, right? It can have any number of solutions, and that will, this set will tell you the workspace. So how much workspace you can go actually to do a typical task. Okay. So this will be evident once we do certain, this I have already talked. So when we go to this link, we can actually virtually, this is a virtual link to do the simulation. Okay, we can actually put these theta values maybe, and the range of these theta values of each joints are given for this particular Mitsubishi robot. Okay, it could vary robot to robot. That is not of importance. But if you go to this particular website, let me go that. So this is I suggest everybody to open this link. Go to this particular website, vlabs.iitkgp.earnit.in slash Mr. sorry mr slash experiment 2 slash forward kinematics rm501 html. Please go in link, or maybe I will copy this link to the chat. Okay, please open this website. And now here, the good part of here is you can either input the joint values theta 1, theta 2, theta 3, and theta 4 and theta 5 values. Click OK, and you will have the transformation matrix that automatically generates. I mean, computer generates based on that theta values. And link values are also known to this guy, and it will show the workable space here. Okay. Another way, so let me vary this. So let me vary the, let's suppose this, I am giving this -25, and this I'll give -4. Maybe this I'll give 10 degree, and I'll click OK. And let's see how the configuration of this robot comes. Okay, theta should be within 1, theta 3 should be 0 to -180, but I have given. Okay, तो value 0 ही रख देते हैं इसको. I don't know. -5. Okay, नहीं रहा. Anyways, let me refresh it. Okay, so what you do, either you can take your known values here, put it here, and get the transformation matrix and the workable space in right top bottom here, or you have a slider based robotic joint controller value. So when I slide the waist joint, see the configuration how it is moving. So this robot is moving waist wise. Okay, and here you can have the workable end effector positions with you. Okay, so see, if I'm moving, it is moving. Now if I move my shoulder, it is going down, up, down. Now it is able to pick something, elbow, picking something. Wrist, it can actually rotate. Its wrist can bend, and then it can also roll, isn't it? And the final workable locus points of your end effector is being traced on this workspace, and this is called workspace. Okay, and you can actually play around with this. And obviously we cannot tell you everything in this 1 hour of session, or 45 rather, 45 minutes session, but I can give you a motivation and brief overview of how the things work and why we do this in this particular fashion, what is the mathematics behind this, and all sorts of things. Hopefully I have motivated and I am understandable enough. Okay, so let me go to the manual and let's see what you guys have to do this weekend. So we have already finished chapter experiment 9. If you come to our campus, we have a workable robotic arm in our campus, and probably it is under Dr. Harshal Oja, sir. He works in robotics. You can coordinate with him. You have to answer the following question for your assignments this weekend. Draw and sketch of a robot and different components. You can do that. What is a workspace of robot? Plot the workspace that you have generated after conducting the experiment. You can do that, right? So everybody can choose its own theta values, slider values, and you can have your own workable space. Okay, and you can generate this workable, and you can download it here. It can be downloaded. You can download the PNG file and you can paste it in your assignment. Uh, yes, that's all from my side. And any doubt? I mean, I'll leave it early. Any doubt or anything else you want to add? Yes or no? Let me take attendance. Okay. Any doubts? No doubts? If yes, no, then we can leave this meeting if you don't have any doubt. And about quizzes, I mean, quiz, at the end semester quiz, we'll be giving easy questions. Probably you can read it and you can take away the right answer. Probably that kind of questions we are giving. So don't panic that you have lesser time. It can be easily solvable. Probably one or two questions might you might have to take pen and paper and you have to solve it, but that also will not be that long. Most of the questions will be easy once you if at all you have read the experiments carefully and the concepts are clear to you. Okay.
Sir, the simulator that we saw, was it made using CAD?
Yes, this model has been made. I mean, definitely this model has been made in CAD, and the script this website might have done. I mean, they might have formulated through Java or some programming. They might have done, but I'm not an expert on that. But yes, this CAD model has been developed in some CAD software, and this IIT Kharagpur. So IIT, this is my home institute. I have done my masters from IIT Kharagpur. I'm really happy to see that these kind of virtual labs they are making these days, and it is available to all of us. Uh, just to motivate you, one of my students, uh, I mean MTech student, has made. So you have a tree. Let's suppose you have a tree and you have a fruits on it. Maybe some fruits are rotten, some fruit कुछ पके हैं कुछ कच्चे हैं. So ये रोबोटिक आम क्या करेगा वो अपने आप को I mean they have certain joints links and they are going to pick only rotten mangoes based on the images that it gets. Isn't it beautiful? So all sorts of things you can actually also you can do in your future. uh, yes, anything else? So if no questions, I have already taken attendance, we can leave this meeting. uh, so I mean probably we are not going to meet again, and this assignment should be submitted till 4th because 4th is the final date. So let's keep the deadline as 4th. Will it be fair enough for you guys? Because other batch also I kept it 4 or weekend.
सर वीकेंड
वीकेंड रखना है, ठीक है वीकेंड ही रखते हैं फिर. आप लोग का एग्जाम कब से शुरू हो रहा है?
फ्रॉम
7.
7 करेक्ट
देखिए 7 है तो फिर आप लोग नहीं कर पाएंगे 6 को। 6 को आप लोग बिजी रहेंगे अपने 7th वाले एग्जाम के लिए। सो वी विल कीप इट 4 और 5, 5 रखते हैं। मुझे भी पता है, मैंने भी बीटेक किया है, नहीं हो पाएगा। ठीक है, लेट्स कीप इट ऑन 4th और 5th, 5th रखते हैं।
Sir, practical exam will be in MS Team.
टीम, यस टीम्स में हम लोग क्विज लेंगे। ठीक है, तो टीम्स पे जैसे असाइनमेंट पुट होता है आप लोग को सर्टेन टाइम पे, 8 तारीख को है, वो पोस्ट हो जाएगा आपका क्विज। ठीक है।
Okay, sir.
और मोस्टली जो हमारा जो असाइनमेंट्स है, मोस्टली मुझे ऐसा लगता है कि सब लोग सेम ग्रेड करेंगे, क्योंकि सब लोग मोस्टली कॉपी किए होंगे या सब लोग नेट से देखे होंगे। पर मोस्टली डिसाइडिंग फैक्टर वुड बी योर क्विज, सो क्विज अच्छे से दीजिए। ठीक है, क्योंकि इधर असाइनमेंट्स में सभी लोग सेम तरीके से स्कोर करेंगे, मोस्टली 9-10 9-10 करके ही। ठीक है।
Yes, sir.
Okay, then if no other questions we can leave this meeting. व्हाट्सएप ग्रुप है, कुछ अगर दिक्कत होता है तो यू गाइस कैन अप्रोच ऑन व्हाट्सएप, और मे बी जो ग्रुप लीडर है, एडमिन है, उसको आप मैसेज कर सकते हैं, ही कैन पोस्ट। ठीक है, फाइन, देन लेट्स एंड दिस मीटिंग। थैंक यू।
Thank you, sir.
Yes, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.